people gone today, so I'm going to make sure we record this. Today we're going to teach you how to graph lines. We really got 4 great ways of doing it, and we're going to start with something that takes a little bit longer, then we're going to get to a shorter way. This could be a really, really good review for you guys. I know second hour, it really hit home. I want to talk to you about 2x plus 3 is equal to 19. Would we all agree that you can solve that? Would we also agree that there's exactly one solution to that, and that the solution is 8? When we get to linear functions of 2 variables, notice you have an x and a y, you don't just have one solution, you have an infinite number of solutions. So how do we show those? We start by making a table of values, an x, y, t chart. This is one way to do it. This is option number 1 for graphing lines. You give me an x value, I find a y value. What do you want for x? 1. I plug in 1 for x. Negative 2 times 1 plus 1. That's a point that I can plot. 1, negative 1. There's a special number that I like to pick. 0. Love picking 0 because negative 2 times 0 is 0. Plus 1 is 1. I plot 0, 1. And we always encourage you to try a third point to make sure that it fits on the line. If you want to try negative 1, sounds good. Negative 2 times negative 1, 2, plus 1, 3. So notice what I have here. I have 3 points that all fall on a line, and sure enough, you can draw that line. I told you that there's an infinite number of solutions. We found 3. The line represents all of them. If the line goes through a point, that's part of the solution set, even decimals and fractions. It's as plain as that. The next one's a little bit more difficult. Why? Fraction. So I'm not going to plug in the 1 because I don't like to take 1/3 times 1. There are certain numbers that are great to multiply by 1/3. Anybody know? 0 works out really well. 3 works out really well. 9, 6. Any number divisible by 3 is great to plug in. 0 times 1/3 is 0. Minus 4 is negative 4. What's 1/3 of 3? 1. Minus 4 is negative 3. 1/3 of 6 is 2. Minus 4 is negative 2. I can take these points and plot them like so. I see that some of you recognize that these are also what we call slope-intercept form. That's what we're going to be looking at right on the next page so that we're all clear. Any questions on making a table? I would encourage you to never make a table for a line, but you might run out of ideas and have to go back to that. I'm going to show you other ways that I believe are more effective. Are you ready? X and Y intercepts. Suppose you have a graph and you have a line that crosses like this. We call this guy right here the x-intercept. Here's a hint. We know one of the values for the x-intercept. Do you think you know the x value or the y value for the x-intercept? What do you think? The y value is what? The y value is 0. Can everybody look at that, convince themselves that if you were on the x-axis that the y value is going to be 0, has a height of 0. Similarly, if you look at this spot, this is the y-intercept. And we know that the y-intercept has a what? A 0 for the x value. So this is a second way to graph lines. You plug in 0 for x, you plug in 0 for y, and see what you come out with. This equation right here, 2x plus y is 4. Suppose x is 0, then it goes away. What's the y value? 4. Suppose the y value is 0. What would the x value have to be? 2. So you have 0, 4, and 2, 0. That's enough to be able to create a line by finding x and y intercepts. So it's kind of like making a table, except we just choose zeros. We try it again. If x is 0, what's y? Yep, 2 times what is -6? We'd say -3. Similarly, if you cross off the y, -3 times what is -6? 2. You can see you have your x and y intercepts ready to go. 0, -3, and 2, 0. There we have it. Another way to graph a line is if you're given the slope and the point that it passes through. I can always start with one point, -3, +4. I use my slope then to find another point. How do I use my slope here? Rise over run. So I go down 2 over 3 and always run to the right. If you'd like more points, just repeat it. Down 2 over 3. Same thing here. Slope of 4, and I'll write it over 1 and passes through 2, -5. We have our rise over our run. Rise 4, run 1. Rise 4, run 1. And there we have it. Pretty straightforward review. Then let's see the most common, and this is the last example of what you really are looking at, is slope-intercept form. Anybody know what we call slope-intercept form? And we've already seen those examples earlier on if you caught on to it, but this is slope, and this is your y-intercept. So we're taking what you once learned over the course of a week, and we're throwing it into a nice 20-minute lesson here to try to bring back to your memory. And when we talk about slope-intercept form, we like to put it into slope-intercept form, which means you solve for y. So 3x plus y is equal to 1. How do I solve for y? Yep, subtract that 3x over. Can I combine 1 and -3x? No, they're not like terms. So we have a -3x, and we have a +1. So my slope is -3 over 1. My y-intercept, 1. Plot the 1 and use our slope. Down 3 over 1. Down 3 over 1. Number 2, very similarly, we add the 2x. Negative y is 2x plus 3. Now what? Do I divide the negative or the 2 by -1 or the 3 by -1 or both? Both. So y is -2x minus 3. So my y-intercept is -3. My slope is -2. If you see an integer like that, just write it over 1, -2 over 1. They'll tell you to drop 2 and run 1. Drop 2 and run 1. We're going to leave example 4, but we are going to do example 3 together. You walk me through this. What do I do to both sides? Subtract 4x. 3y equals negative 4x minus 6. Divide the 3. Y is negative 4 over 3. I always encourage you to keep the negative with the top. So my slope is negative 4/3. My y-intercept is negative 2. Plot the negative 2. Down 4 over 3. Somebody commented second hour that they felt that this is kind of where their grade starts to drop. They remember maybe being confused about this back when they were in different classes. And I assured them that no, this will come back to your mind very nicely. When we start writing equations for lines that are parallel, perpendicular, that might be a little bit more frustrating, but trust me, you'll get through it. So, all right, I'll get your assignment.